Life is made up of deep, meaningful moments. But that's a topic for a different channel, as today we're going to talk about moments in the force sense. I'm your host JD and welcome back to the Phys Academy, so let's get things started. What is a moment? Well, it is the turning effect of a force around a fixed point, also known as a pivot point. And you've probably heard the more common term for a moment, which is torque, and it is expressed in Newton meters. But how do we calculate a moment? Well, firstly, we must understand the two key factors that determine the size of a moment, and they are the size of the force applied and the perpendicular distance from the pivot point to the line of action of the force. Taking these two key factors, we can use the following equation to calculate the size of a moment. And that is m is equal to F times d, where m is the moment in Newton meters, F is the force in newtons, and d is the perpendicular distance from the line of action of the force to the pivot point in meters. Let's look at a super common example where we have a spanner and we want to tighten a nut. If we apply a 30 Newton force on the handle of the spanner and the perpendicular distance is 0.1 meters, we can calculate the size of the moment required to tighten the nut. So, taking the equation that we've just seen, we can simply input m is equal to 30 times it by 0.1, which gives us m is equal to 3 Newton meters. And that's how we do basic calculations. Just to expand for any of you who plan on or are already studying engineering in college or university, you'll find that lecturers love the cantilever beam example, so let's have a go at one ourselves. A cantilever beam has a 50 kilogram box placed at its free end. The beam is 5 meters in length from the wall to the center of the box. Calculate the moment about the pivot point in the wall. So, first of all, we will draw the free body diagram, like so. From here, we need to calculate W, and W is simply the force, which, going back to our old friend Newton's second law of motion, force is just equal to ma. And in this case, we know that the mass is 50 kilograms, and the acceleration a will be the acceleration due to gravity, which is simply 9.81 meters per second squared. So, substituting those numbers into our equation gives us a calculation for W is equal to 490.5 newtons in a downward direction. From here, we can simply substitute back into the original equation that we learned, which is m is equal to F times d. We know that d is 5 meters, and that F is now equal to W, which is 490.5 newtons. So m is equal to 490.5 times by 5, which equals 2,452.5 Newton meters. As you can see in this free body diagram, there is a force R which acts in the opposite direction to W, and this is why the moment around the pivot point is critical, because without it, the beam would simply rotate continuously, sort of like a propeller blade. Hopefully now you'll have a basic understanding of moments and how to calculate simple problems. So be sure to destroy that like button and subscribe for more simple scientific content. See you next time.